All right, so P2, section 2, part 4, which really is like called C on your notes, but this is the 4th day of notes for here, is simplifying radicals, okay? So we're doing a little bit like what we did yesterday where you were taking those square roots, but now you're actually going to get like perfect or non-perfect squares. So we're going to learn how to break the review, because hopefully this is not something this is something you've seen before, but breaking it down into your factor tree, that kind of stuff. So when you are simplifying a radical, you're going to use the factor tree to simplify. So you're literally going to take that number, you're going to break it down until it's called a product of primes, because you want to keep going until they are all dead ends, or they are all, God bless you, they are all prime numbers. When the index is 2, which means it's a square root, 2 of a number brings that number to the outside. We're going to break down square root 20 in a second, but I want you to be able to write out what's there. All right, so if we were to look at square root 20, for example, right, we know, well, hopefully we know, that square root 20 is not a perfect square, so it's not like we just simplify it. We don't use calculators because we want to be kept exact. So we're going to take that 20 and we're going to break it down into a product of its primes. Now, you can do any factors from 20, so I could break that down into, I could break it down to 4 and 5. I could break it down into 2 and 10. But when you get to that first row of factors, you're going to say, can I go further? So if it was a 4, I'd break it down into 2 and 2. If it's the 10, I'm going to break it down to 2 and 5 until I get it so that it's just primes. So by primes, we're talking 2, 3, 5, 7, 11, that kind of stuff. 13, those are your prime numbers. Then the rule is for each pair, so a duplicate of a number, for each pair, one of those numbers goes to the outside of the radical. So if there are 2 2s, I bring 1 2 to the outside of the radical. If there was another pair of 2s, I'd bring another pair. So for every pair, it goes to the outside. Whatever doesn't have a match, so this 5 is going to stay underneath. So this would be 2 square root 5. Now, sometimes the number's kind of small and we're pretty good at, if you are, you could see this is 4 and 5 and square root 4 is 2. You can totally break it down that way. However, the numbers are going to get bigger, and when they get bigger, it's going to be harder to identify those perfect squares. It's going to be easier just to break them down into their primes, and for every pair, it goes to the outside. Yeah?
What happens if it's like you're splitting it up, but there's no extra number?
Then everything stays underneath. So whatever comes to the outside goes to the outside, and if there's nothing left underneath, that means it's a perfect square. So like if it was 25, it'd be 5 and 5. 2 5s brings 1 to the outside. There's nothing left underneath. If there's more, if there's 2 more can get brought to the outside, you multiply those out. If there's more that are left underneath, then you leave those. So let's say it's square root 60. This breaks down into 2 and 30, 3 and 10, 2 and 5. So my prime numbers are 2, 3, 2, and 5. There's a pair of 2s there, so the 2 goes to the outside of the radical. The 3 doesn't have a match and the 5 doesn't have a match, so those get multiplied together underneath, and I'd get 2 root 15.
And then if you have 2 pairs,
then you multiply them on the outside. Yep. Yeah.
So if you have 2 pairs, then that goes on the outside.
Yep. So if this was 240, let's say, we're going to do this again, but let's say this is 240. 240 is 2 and 120, 2 and 60. 2 and 30, 2 and 15, 3 and 5. Here's one pair of 2s, so a 2's going to the outside. Here's the second pair of 2s, another 2's going to the outside. The 3 and the 5 don't have a match, so this ends up being 4 square root 15. It could be a pair of 2s and a pair of 3s. It doesn't have to be the same number. If it's a pair of 2s and a pair of 3s, there's a 6 on the outside. And then whatever's left underneath. So a perfect square would not have anything left underneath. All right, multiplying. So that's breaking it down into its factor tree. That is called simplifying it, putting it in simplest radical form, okay? And that's how you will leave all your answers. So you never want to use a calculator for square root 20 because it's not exact.
Can you do that with variables?
Yeah, we're going to do it when we get into them. Yep. So there's a shorter cut. There's a shortcut with variables, but we're going to do it. Yeah. All right, then multiplying, right? So if we're multiplying 2 square roots, you can multiply them together as long as the index is the same. And by index, I mean the little number on the outside. So these are both square roots, which means I can combine them underneath, and this becomes square root 6. If they were both cube roots, I could also do the same thing. If one is a square root and one is a cube root, you cannot multiply them. Those would be left separate. When you're dividing, you can divide the same if the indexes are the same.
The index is a number on the left.
Correct. So if they're both square roots, you can simplify. If one's a cube root and one's a square root, you can't. So like these are both square roots, right? The 10 and the 5. You can actually say 5 goes into itself once and it would go into 10 twice. And I'd get the square root 2 over the square root 1 or square root 2 over 1, which is just square root 2. So you can simplify square roots by dividing the same way, okay? If it was square root, let's say it's 20, and in the bottom, square root 15, I can say 5 goes into both of those. This would be 4, this would be 3, and I'd end up with the square root of 4 over the square root of 3, which becomes 2 over square root 3. So if you can simplify what's underneath the radical, and they're both square roots or both cube roots, as long as the index is the same, you can do it. Yeah.
Question: what happens to the upper square root?
The square root 4, we can actually simplify that because that's a perfect square.
Oh, okay.
Yeah. And in a moment, we're going to learn that you can't leave a square root in the bottom, and we're going to learn how to rationalize.
Can there be a decimal after about?
Can there? I mean, in theory, there can be, but there won't be because you're going to need to simplify it. Yeah. All right. Do 1 and 2. All right, what'd you break 28 down into? Because it could be different. 2 and 14, and then the 14. 2 and 7, so what repeats there? Good. The 2 repeats, the 2 goes to the outside, and it'd be 2 square root 7. For 2, you got 48. What can 48 break down into? 2 and 24. 2 and 12, 2 and 6, 2 and 3, 1 pair of 2s. Oops, I didn't mean to do that. 1 pair of 2s, a second pair of 2s, and the lonely 3. So this becomes 4 root 3. We good? Yes? Okay, so now what do we think is going to happen if there's a number already on the outside? You're going to multiply. So whatever you take out there, you're going to multiply. So we already broke down 48, right? 48 broke down into 2, 2, 2, 2, and 3. So there are 2 pairs of 2s that are going to come to the outside and multiply by the 2 that's already there. So I get 2 times 2 is 4 times 2. That's 8 on the outside, and the 3 again that's left underneath. So if there's already a number on the outside, it just gets multiplied by it. So 45 would break down into what? 5 and 9. 9 is that 3 and 3. Bring out a pair of 3s, multiply it times the 6 that's already there, and I get 18 square root 5. We good? Questions? Yeah. So 48, I just didn't re-break it down, but we did it up here. We broke it down, so the primes on 48 were 2, 2, 2, 2, and 3. I just didn't do all that work because we had already done it. Yeah.
Where did you get the 5?
On the 45?
No, on the answer.
Right, so on the 45, it broke down into 5 and 9, and then I broke the 9 down further. The 3s came to the outside, but that 5 is still underneath because it didn't have a pair. All right, do 5 and we're going to save 6 for tomorrow because we'll come back to it, that we'll use it kind of almost as a warm-up. We're going to use 6 and 7 tomorrow. So do 5 by yourself. All right, 75 breaks down into what? 3 and 25, which is 5 and 5. The 5s go to the outside, get multiplied by the 14 that's already there. And you get 70 square root 3. Raise your hand if you got it right. Okay, good. All right, so again, we'll come back like 6 and 7. We'll use those as practice when we come back tomorrow morning. So 8, now you've got 2 square roots that are being multiplied. We said we could multiply as long as there's the same square root, right? I mean, as long as they're the same index, so they're both square roots. So in this case, and I'm going to show you 2 ways to do it. The first, I would multiply the 2 on the outside, so 5 times 2 gives me 10. And then I would multiply the 2 on the inside, and I get square root of 9. But square root of 9 is what? 3. So then I'd get 10 times 3, which is 30. So you're kind of doing an extra step there. So the shortcut is any square root multiplied by itself is the number that's underneath. So as soon as I would still do the 5 times 2, I would say that's 10. But then as soon as I say square root 3 times square root 3, my answer from that is just 3. Any square root multiplied by itself just eliminates the square root and you keep what's underneath, okay? So it saves you the step of having to do the square root of 9 and then square root it. So if it's square root 5, my answer is 5. Square root 11, my answer is 11, okay? Questions so far? Yeah.
So if it's like square root 5 times square root 5, it becomes just 5?
Just 5. The long way around would be, okay, that's square root 25. Square root 25 is 5. But you can save yourself that extra step. All right, so look at 9. What's square root 5 times square root 5? 5 times the square root of 9. What's the square root of 9? 3. This is 15. Okay, before you waste time on 10, I'm going to show you something. So if I wanted to multiply that out, right, there's obviously not the same, they're not the same, but I could multiply. I could do 44 times 11, which is 484, okay? I could multiply that out, and then I'd have to break it back down again. Because we are eventually going to break these back out, I could literally take them as they are, 11 times 44, keep them as a separate product. Then break down what you can. So 11 doesn't break down, right? But 44 breaks down into what? 4 and 11. And now I have a repeat. That 11 goes to the outside. And then I get the square root of 4, which would be 2 and 2, which is just 2. And I get 22. So before you multiply out what's underneath, break it down. Keep it as a separate product. Break it down. And then simplify. Don't waste your time doing 484 and then doing like 2 and 242 and 2 and 121 and 11 and 11 and then having to bring out the 2 and then bring out the 11. So it's extra work you don't need to do. Keep it as a product underneath one root and then use your factor tree to simplify it. All right, so now knowing that, what is 33 breakdown? 3 and 11. So this would be 11 square root 3. The 11s come to the outside. The 3 doesn't have a match. All right, what can we do with 12? You can divide the 7 into the 35, yes? So this would become 1, which means that cancels out, and this will become 5, and I end up with 6 over the square root of 5. We're going to leave it as that right now. Eventually we're going to learn we're not going to leave that, okay, when we get to the dividing side. We could leave it like that for now. And 13, what goes into both 48 and 39? 3. 3 goes into 48. 16 times. 3 goes into 39. 13 times. So I have 5 square root 16 over square root 13. Can I simplify that further?
Yeah, 4.
Good. Square root 16 is 4, and this becomes 20 over square root 13. Okay, now we've got the distributive property with our multiplication. So when you look at 14, whatever's on the outside of that sum or difference in this case, we're going to distribute into both. What is square root 5 times square root 5? 5. minus, and the number without the radical is going to come first, so it's 2 square root 5. And you leave it just like that. You cannot combine these. One has the radical and one does not.
Well, why can't it be 3 square root 5?
Why? Because you can't combine a number that's got a radical with the one that's not. It's like having an x on a variable, with a coefficient, and an x and no x. You can't combine them. Okay? They're not considered like terms. We can multiply, but you can't add unless they're the same. All right, 15. Okay, not a product or a sum, just a multiplication. So I'm going to multiply all the coefficients together first. 3 times negative 2, that's negative 6, times 3, that's negative 18. And then for me, the easiest thing to do is write all the things that are underneath the radical together before I start to break them down, if there's more. So the 2 is prime, but the 8 breaks down into 2 and 4, 2 and 2. The 27 breaks down into, good, and then 9 breaks down, 3 and 3. So now I've got this 2 that was part of my original one. So I have one pair of 2's there. A 2's going to come to the outside. I have a second pair of 2's. Another 2's going to come to the outside. I have a pair of 3's. A 3's going to come to the outside. And the only thing left is this 3 that doesn't have a pair. So now I got to multiply it all out. So if you wanted to do the top, like this would be 4 times 3, that's 12. And I'd get negative 18 times 12. Which is negative 216. And then the square root of 3, because the 3 didn't have a match. So now we're back to a sum and difference. We had a sum or difference up here in number 14. And one had a radical 5 and one did not, so we couldn't combine them. On 17, they both have a square root 3. So when we're adding and subtracting radicals, subtract, they must have same index and the number underneath. It's called the radicand. Underneath the root. If they are different numbers, you cannot combine them. They are not like terms. In this case, they both have the square root 3. So I can combine them. I keep the square root 3 as square root 3, just like you would do with an x or an x squared. And I combine the numbers in the front. So 8 minus 6 is 2, and the square root 3 stays on it. Valerie, did that answer your question? All right, so now we're taking it a step further because these are not like yet. We're going to simplify first, then see if they're alike, and then combine. So if you look at 18, I'm going to take the 24 and break it down. So we know this is 2 and 12, 2 and 6, 2 and 3. I can bring out the pair of 2's, so a 2 comes to the outside. The other 2 does not have a match, and the 3 does not have a match. So negative 2 root 24 becomes negative 4 square root 6. Square root 6 cannot be simplified, so I leave that minus 3 square root 6. It would be 2 and 3, but nothing would repeat, right? So it would stay. And now they are like terms. They both have a square root 6, so I do negative 4 minus 3, which is? Negative 7 square root 6. Joey, you good?
Oh, never mind. I understand.
Okay, we're going to save 19. We'll come back to that tomorrow. 19 and 20. So those are the same concepts. You're going to simplify. Well, actually, that one is the square root 36 actually simplifies. Let's do this one. Because this would be 6. And this would be 5 and 9 and 3 and 3. So a 3 comes to the outside. This is 9 square root 5 plus 42, because the 6 came to the outside. And then because one has the square root 5 and one does not, you cannot combine this. This stays as is. Okay, 20 we'll go back to. We'll start that as a warm-up tomorrow. Because now we're in multiplication. So you are multiplying binomials, which is something with two terms, okay? When you're multiplying binomials, we FOIL. So the 4 gets multiplied by the 4. That's 16. The 4 gets multiplied by the negative square root 11. So I get minus 4 square root 11. The 4 that's positive now gets multiplied by positive square root 11. So this is plus 4 square root 11. And the negative 11, or negative root 11, and positive root 11 becomes what? 11. Negative 11, but good. Okay. So the negative, because it's negative positive, but root 11 minus, or times root 11 becomes just 11. Now what?
You add them all together.
Good. These are like terms. 16 minus 11 becomes? 5. And then what happens to negative 4 root 11 and positive 4 root 11?
Cancel out.
This is just 5. Okay, 22, I'm not going to work all the way out. I'll finish it tomorrow. But because it's squared, and we talked about this the other day, this does not mean I distribute this squared, okay? It's a sum or difference, which means I have to expand this as the same, because it's 2 of the same, and then I would FOIL this. So first, outer, inner, last.
Wait, why don't you distribute?
Because you can't distribute on a sum or difference. You can only distribute if it's product or division. Right? This is saying there are 2 of these. So if I wanted to multiply it out, I'd have to duplicate it. You can't distribute. That's different than if it just said like 3 square root 11 squared. That you can distribute. But as soon as you get a plus and minus or minus in between them, you can no longer distribute. So this is what's called rationalizing the denominator. And you're going to hear it a lot. Okay? Rationalizing the denominator is what you do if you have a square root in the bottom. You cannot leave a square root in the bottom, okay? It makes it an irrational number. So the way we eliminate it is called rationalizing the denominator. That's the process. What you're going to do is if it's just a single square root in the bottom, you actually multiply the numerator and the denominator by that variable or that root. I'm able to do that because technically that's just like multiplying by 1, and you can multiply by anything by 1. It doesn't change the value, right? So for the first one, I only have a single square root in the bottom. I'm going to multiply both the top and the bottom by the square root of 2. And I end up with 5 square root 2 over, what's square root 2 times square root 2? 2. If I could simplify from there, I would. If not, like it is, I'm just going to leave it the way it is. So if it was like 10 root 2 over 2, I'd then reduce it. Yep.
So you multiply the entire fraction by the
Denominator. Yep. That's if it's just one square root in the denominator. You have to get rid of it. Yep, you can't. So like the ones that we did in the beginning, I said, remember, we're gonna come back because you can't leave them like this. So any answer you write in here, you won't leave with a square root in the bottom. Okay, second one now has a sum. So if it has a sum or difference in the bottom, I can't just multiply by square root 3. It won't eliminate it. So what I do is what this second thing says, multiply by the opposite of the expression that's in the bottom. What does opposite mean? Good, change that sign. So I'm going to multiply this by the bottom, but instead of it being a plus in between, I'm going to make it a negative in between. So 2 minus square root 3 in both the top and the bottom. Whatever I do to the bottom, I have to do to the top. Madison.
Why would it not be negative 2 minus 2?
So you only have to change the one that's in between it. That's what we want to eliminate, the square root. The 2 is fine.
Okay.
So what you're trying to eliminate is the square root, so you're going to change the sign on the square root.
Okay, thank you.
So then I'm going to actually distribute what's in the top. So this is going to be multiplication. This goes here, 4 minus 2 root 3. And in the bottom, I have to FOIL. I'm going to show you a shortcut in a minute. But if you FOIL this out, 2 times 2 is 4. 2 times negative root 3 is negative 2 root 3. 2 times positive root 3, positive 2 root 3. And root 3 times negative root 3 is what? Negative 3. If you've done it correctly, the middle 2 should cancel out, which was the whole goal there, to get rid of the radical. And then 4 minus 3 is just 1, so my answer here is 4 minus 2 root 3. If it's not 1 in the bottom, but it's a whole number, it's totally like if it was 5 in the bottom, I would have left it over 5. You can leave it like it is. Yeah.
But we can't multiply the denominator by the radical if it's positive?
You can, it just won't cancel it out. So the only way to cancel these two out is to give them different signs. So you have to change the sign in between, and that will give those different signs. Okay, does that make sense?
Yeah.
So the shortcut, if you understand the shortcut, do it. If you don't, ignore me and don't freak out. Just do it like we just did it. But the shortcut is to square the first term, which is 4, square the second term, square root of 3 squared is 3, and put a minus between them. And that's the denominator. So when you multiply by the opposite like that, that's what you get. You square the first term, you square the second term, and you put a minus between them. If that confused you, then you FOIL it out, because that's what you originally would do anyways. Yep.
So if it's any whole number plus a radical in the denominator, you could do the square root trick. And
Yep.
That's the denominator.
Yep. And if it was minus, let's say it was 2, which I think there's an example. Let's say it's 36 or 26, right? I'm going to jump, but then I'll go back. The square root in the top is fine. I'm not trying to eliminate that. What I'm trying to eliminate is the square root in the bottom. What's the opposite of 1 minus square root 2? 1 plus square root 2. So I have to multiply both the top and the bottom by that, which gets messy in the top. I'm going to FOIL that out. In the bottom, I can either FOIL it out or I can use my shortcut, which says square the first one minus square the second one.
I thought you said we couldn't do this. Because if you FOIL, wouldn't...
We're FOILing this out only because they're opposites does the shortcut work. So this isn't a square. This isn't 1 minus square root 2 squared, right? You can't do that. This is 1 minus root 2 times 1 plus root 2. When you multiply by the opposite, you can use the shortcut. Not if it's squared. And if it confuses you, FOIL it out. So this becomes 1 minus 2, which is negative 1. The denominator here would be negative 1. The numerator, you'd have to FOIL. 3 times 1. 3 times root 2. Root 2 times 1. And root 2 times root 2. And then you'd combine your like terms. So I'd get 5 plus 4 root 2 all over negative 1. And what does dividing by negative 1 do? Just change the sign. So it's negative 5 minus 4 root 2. So we'll work out the rest of these tomorrow because that bell's about to ring. But what would you have to multiply 23 by? Square root 3 over square root 3, right? We have to get rid of the root in the bottom. So it would be root 3 over root 3. What would you have to multiply 24 by? Square root 3 over square root 3. I don't care about the root 2 in the top. That's fine. I'm trying to get rid of the bottom. What would you have to multiply 25 by? 3 minus root 2, okay?